Hello everyone. So in this presentation, I'm going to explain you guys about dimensionality reductions in machine learning. So let's get started with the slides here. So the dimensionality reduction in machine learning refers to the process of reducing the number of input variables or features in a dataset while retaining as much of the relevant information as possible. This technique aims to simplify the data, making it easier to analyze and model, and improving the performance of machine learning algorithms. It helps to mitigate issues such as overfitting, computational inefficiencies, and the curse of dimensionality, which can occur when working with high dimensional data. Dimensionality reduction techniques transform the data into a low dimensional space, either by selecting a subset of original features or by creating new, more informative features. So I have listed some importance of dimensionality reductions here. So we'll read it by point here. So the first point says improves model performance. High dimensional data often lead to overfitting, where the model becomes too complex and fits the noise in the data rather than the actual underlying patterns. By reducing the number of features, we can reduce the chance of overfitting and improve the model's ability to generalize to new unseen data. Second point, reduces computational complexities. The computational cost of training model increases with the number of features here, but the dimensionality reduction helps to minimize this cost by making the training process faster and more efficient. Enhances data visualization. High dimensional data can be difficult to visualize and understand. By reducing the number of dimensions, the data can be projected onto 2D or 3D space, which aids in easier visualization and interpretation. Fourth point, it mitigates the curse of dimensionality. As the number of dimension increases, the data points become more separate, spread, become more spread out, and the distance between them grows, making it harder for the algorithm to distinguish between classes. This is known as the curse of dimensionality. Dimensionality reduction helps combat this by keeping only the most informative features. Now comes the feature extraction versus feature selection. So the dimensionality reductions can be approached through feature extractions or feature selections, both of which aim to reduce the number of features but in different ways. So let's have a look on this. So the feature selection involves choosing a subset of the original features based on the certain criteria. The goal is to retain only the most relevant features and discard the less important ones. The approach that the feature selection uses is that it selects a subset of the original feature without transforming them. What are the benefits of feature selection? So the benefits are that the resulting features are interpretable, meaning the model uses the original features which can often be understood and explained. It can be computationally efficient, specifically especially if a small number of features is chosen. The drawback of feature selection is that it may lose some variable information if important features are discarded. Now comes the example of feature selection techniques, which are filter methods. These methods evaluate the relevance of each feature based on statistical tests. Common techniques include chi-square test and the correlation coefficients. Second example is about wrapper methods. These methods evaluate subset of features based on model performance. They involve using a machine learning algorithm model to test different subset of features. For example, recursive feature elimination, forward selection. Now comes the last example, that is embedded methods. These methods perform feature selection as part of the model training process. Example includes lasso regressions, L1 regulations that forces some coefficient to zero, efficiently effectively eliminating certain features from the model. So now comes the turn for the feature extraction. So feature extraction on the other hand involves creating new features or components from the original features. This is typically done by combining multiple features into one dimension but capture important aspect of the data. The approach that feature extraction uses is a new feature component, and is that the new feature components are created through mathematical transformation, often resulting in unrecognizable or non-intuitive representations. What are the benefits of feature extractions here? So that so that are it can retain the most important information by combining features in a way that maximizes variance, PCA, or class separability, LDA. It's useful when the original feature have redundant or highly correlated informations. So then, what are the drawbacks of feature extraction? The the new features may not have an easy interpretation as they are often combinations of multiple original features. Examples of feature extraction techniques. The first one is about PCA, Principal Component Analysis. PCA is an unsupervised learning linear method that creates new feature principal components for obvious that capture the maximum variance in data. These components are linear combinations of the original features. Second one is about LDA, that is linear discriminant analysis, which says that LDA is a supervised method that is used primarily for classification things. It finds new components that maximize the separation between classes in the data. Third one is autoencoders. Autoencoders are a neural network based model that learn a compressed low dimensional representation of the data through the reconstruction. The middle the middle layer of a autoencoder represents a bottleneck that captures the most essential feature of the data. So here are the difference between the feature selection and feature extraction. So aspects of the method says here that in feature selection it selects a subset of original features, but in the feature extraction it creates a new feature by combining original features. The feature selection interpretability में क्या कहता है वो? It says that it retains original features so it's easier to interpret, but with the feature extraction, new features often lack intuitive interpretations. With the loss of information, feature selection says that it can lose important features if not chosen carefully. But with the feature extraction, it retains most of the information by combining the features. Now, computational cost. With feature selection, generally less computational expenses are expected from it, but can be more computational intensive, especially for large dataset with extractions. The use case of feature selections are when original features are meaningful and informative, but with the feature extraction, when the original features are redundant or highly correlated, it is the most useful then. So the conclusion of all this is that dimensionality reduction is a key technique in machine learning for improving model performance, reducing computational cost, and making data easier to interpret. Both feature selection and feature extraction have their own strengths and weaknesses. Feature selection is simpler and preserves the interpretability of the features, whereas feature extraction is more powerful in capturing the essential structure of the data but may lose interpretability. The choice between the two depends on the specific needs of the dataset and the machine learning task at hand. So yeah, that is from my side. Thank you for watching my video, and this is me, Rohan Lakhan, signing off. Hello everyone. So in this presentation, I'm going to explain you guys